This is the chain rule video. Okay, so rules given. So what is this about? You're gonna have a composite function, a function that has another function in itself. For example, like down here, you have 5x plus 7 is the inside function, and the outside, the big structure, is something getting raised to the fourth power. You see what's going on here, right? So if you have a function like this, how do you differentiate it? It's very easy. What you do is you take the derivative of the outside structure first, okay? So just like if I give you y equals x to the fourth power, how would you take the derivative of that? You'll make that y equals 4x to the third power, right? So let's do that first. Let's take the derivative of the outside function. So what I will have is bring down this 4 to the front, and I'll have 4 times 5x plus 7, which stays the same inside, but the new power is 3. Don't stop there. You're going to multiply this by the derivative of the inside function. That's what chain rule is. You're going to multiply this by the derivative of the inside function. What's inside? 5x plus 7. So this is going to be a two-step problem. Many of these chain rules, you have to take the derivative of the outside structure, and then don't forget to multiply that by the derivative of the inside function. Let's simplify this. I have 4 times 5x plus 7 to the third power. But now we're working with the derivative of 5x plus 7. What's that going to be? That will just be 5, right? This part is just 5. So if you do your final simplifying, you can multiply these coefficients. You can multiply 4 times 5 and say that your final answer is 20 times 5x plus 7 to the third power. Okay, so this was an example of a chain rule, and the rule is explained right here. If you have a composition of function, take the derivative of the f of x, the big outside function first, and take the derivative of the inside function. This function notation looks confusing, but it's just about take the derivative of the outside multiplied by the derivative of the inside function. So I'm going to show you another example. All right, the inside and outside is clear, but what I'm going to do is I'm going to rewrite this so that it's not a square root anymore, but it is x to the fourth plus 2x squared plus 1 raised to the what power do you think? Half power. That is how we rewrite our square root. All right, let's take the derivative of this, okay? So the big outside picture, I'm going to bring down that exponent of half, right? Keep everything the same inside. What is the new exponent? Negative 1/2. A lot of people stop there, and that is incorrect, right? We took the derivative of the outside function, the big one. We need to now multiply this by the derivative of the inside function. So I'll say d dx, the derivative of x to the fourth plus 2x squared plus 1. Okay? All right, I'm just going to copy down the first part the same. The first part remains the same. But now I'm working with this one. Okay, what's that going to give us? That is going to be 4x to the third power plus 4x plus 0. So that's it. So you can leave your answer like this, or let's see what else we can do to simplify this. Okay, I see that I can write this as a gigantic fraction with this orange on top of the fraction because this is getting raised to the first power, right? It doesn't have an exponent. It's just raised to the first power. So I'll leave that on top, but we can bring this one to the bottom of the fraction. Why do I get to take this to the bottom of the fraction? Well, because it has a negative exponent, and that negative exponent was half power. So I can say these are under square root. Okay? Don't forget this 2, which can just be in front of this square root expression. But hey, this and that are both fine. They are both fine. But if you want to just put it together, getting rid of the square root. I'm getting rid of the negative exponent. So this is just another option to write your answer. But if you understand that chain rule is about multiplying the outside derivative by the inside function's derivative, then that's what I want you to walk away with. All right, let me do a couple more with you on chain rule. Ooh, looks a little crazy. So let's take the derivative of the outside function first. So bring down that negative 12 to the front. So I'll have negative 12 times 4x squared minus 5. But new exponent is what? Negative 13. But multiply this by the derivative of 4x squared minus 5. Okay? All right, so first part remains the same. I'm not changing anything about this part. I'll just duplicate it. Okay, but the second part, if I take the derivative of this, what's that going to be? I will get 8x minus 0. So I can just say that is 8x. So maybe there's nothing much that I can do about this, but if I were to just multiply this negative 12 with 8x. All right, let me get my calculator. What is 12 times 8? That is 96. So I would write my final answer as negative 96 x times 4x squared minus 5 raised to the 13th power. You can even put this in the bottom of the fraction if you want to, but this problem started with the negative exponent, so I don't really feel the need to write this in a fraction format, but why not? We can put negative 96x on top of the fraction, and we can put 4x squared minus 5 raised to the positive 13th power in the bottom of the fraction. But you know, you don't have to. Both are perfectly fine answers, okay? But that was one example of that. Now, I don't know, maybe I have to stop for now because the next one I'm sensing what? Oh, it's gonna be a quotient rule problem. Okay, how long have I been recording? 7 minutes. Okay, maybe I can do D and I will take a break. Okay? Okay. Because, you know, the outside function is easy. If I take the derivative of this, k prime of x, I just need to bring down that exponent of 5 to the front, keep everything the same inside, and change the new exponent to 4. But you know, that's not it. That is not it. We need to multiply this by the derivative of the inside function, which is that quotient x plus 8 over x minus 3. So the first part of this black piece is done, it's waiting. But now I have to do some work to do the derivative of this quotient using quotient rule. So, okay, here comes my quotient rule pieces. When I do my quotient rule, I like to write down all the pieces. F, which means the top of the fraction, is x plus 8. Where did 3 come from? The derivative of x plus 8 is 1. G, the bottom of the fraction, is x minus 3. And G prime is simply 1. Okay, so if I go ahead and do the quotient rule, I have to do G squared in the denominator, GF prime minus FG prime. How about I use some room here, okay? So, all I'm doing is strictly this orange piece, right? This, how should I make a note? I'm doing, the entire work is just on this quotient rule. I'll come back and multiply to this black piece later, but right now I'm focusing on the quotient rule. All right, so what's that gonna be? The denominator is going to be x minus 3 squared. The numerator is going to be x minus 3 times 1 minus x plus 8 times 1. We just did quotient rule last class, so I know you guys remember this. All right, let me simplify the numerator. The numerator will simplify to be x minus 3 minus x minus 8. The denominator is x minus 3 squared. So if I simplify the like terms, I will get negative 11 over x minus 3 squared. Okay, so let's put them together. What I just found is the orange piece, okay? So let me add a page. I'm gonna need another page. So take a look. K prime of x is equal to 5 times x plus 8 over x minus 3 to the 4th power times what we just found out, negative 11 over x minus 3 squared. And I'm wondering if there is something else we can do to simplify this. And I think I see something. Notice that the denominator is x minus 3 squared, and there's also an x minus 3 here. So I think we can put them together. All right, hold on a second. So what's that going to be? I will have 5 times x plus 8 raised to the 4th power over x minus 3 to the 4th power. So I just rewrote the first fraction. I separated this big, gigantic parenthesis to just group the numerator and the denominator, and I made sure to raise both of them to the 4th power. That is completely okay. Okay? All right, I'm multiplying this by negative 11 over x minus 3 squared. When you multiply fraction, you do them straight across, remember? So if I multiply the numerators, this and that, I will get negative 55 x plus 8 to the 4th power. If I multiply the denominators by themselves, like this times that, since the bases are the same, I can just add the exponents. So that will be x minus 3 raised to the 6th power. So that will be my final answer. Okay, and it looks clean, right? It looks very simplified. So that is something that you can do for a problem that is actually, the big picture is chain rule, but then the little pieces that made up these chain rule pieces, we actually had to use the quotient rule. So that one was kind of challenging, but I think you can do it. It just takes some time and lots of room, right? Okay, so I'll stop this video here. I will come back and show you a couple more. Okay, E and F maybe. I think they're going to be a longer one too. All right,